Welcome, everyone, and welcome to the session on how to get started with AI and where it can take you. My name is Mitra Hajigoli, and I'm a machine learning engineer at eGain. I have 7 years of experience in creating and implementing advanced analysis for complex datasets using statistical programming. At eGain, I develop machine learning models from prototype to implementation to draw insights from big data and turn it into a meaningful story to help customers create measurable business value. I took the opportunity to invite my colleague Victor to summarize what we at eGain are doing so that you can put what I'm saying into context. Welcome, Victor.
Thank you. So, eGain is a leading technology SaaS company that with digital control and energy optimization. We do that within residential buildings and also governmental buildings. At the core, we develop an IoT solution, mobile apps, and AI-based software that visualizes building opportunities and optimizes the energy consumption. In short, we optimize both organizations and buildings. We started in 2003 in Sweden, and since then we have offices in 5 countries and are active in 11 markets directly or through our partners. Currently, eGain is serving more than 5,000 buildings, collecting over 20 million data points every day. Now, why do we do this? Well, perhaps you know this, but buildings account for 40% of the energy use and 36% of the greenhouse gas emission. If those numbers can be lowered, it will have a significant impact in the fight against climate change. And the opportunity is huge. 75% of Europe's building mass is classified as energy inefficient. So let's quickly translate our work into numbers. If you look at 2020, we had 5,500 buildings connected. And by optimizing those 5,500 buildings, we were able to save 216 million kilowatt hours. It's a lot of energy. That translates into saving over 23,000 tons of CO2. Now we take that data from the energy companies and translate it into the amount of kilowatt hours saved. If you're more interested in a financial aspect of it, that would translate into 32 million euros in increased asset value. AI is an important part of how we do it, and there are great opportunities to explore.
Thank you. Let's start on how to get started with AI and where it can take you. The world of artificial intelligence is today truly one of the most talked about topics. Many use buzzwords in their organization, such as artificial intelligence, machine learning, or deep learning, without understanding their meaning in practice. For most, AI is something advanced and hard to understand, and that's fully understandable when you do not work with it. A few think AI is mysterious, but also for its endless possibilities. But a lot of skepticism surrounds this topic, which is healthy to a large degree, but it can stop companies from starting to consider using AI or change their way of working. AI is being highlighted as a solution in all contexts. And instead of focusing on the value it can create, the mere presence of AI is often more valued than the result. We will talk about how to get started with AI and where it can take you, but also when you should look to it. So, let's clarify the buzzwords. Let's look at the value AI can create, the possibilities it can create, and let's look at the sustainable challenges with it, and how to get started with AI, with the requirements and possibilities. The definition of AI, artificial intelligence, by Britannica Encyclopedia is the ability of digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. A system using AI has intellectual processes similar to humans, such as the ability to reason, discover meaning, generalize, or learn from past experience. But what is intelligence here? What is expected of it to be able to do? It needs to be able to interact with the outside world in some way. And it should also be able to reason and plan, to take decisions, for example. But it should also be able to learn and adapt, to continuously be able to learn. A subset of artificial intelligence is machine learning. Machine learning aims to make machines and systems learn and perform a task using statistical methods. Machine learning can be used for forecasting, predicting, classifying, for example, good or bad, or who or what. Deep learning is a subset of machine learning, which uses machine learning techniques inspired by our brain's own networks of neurons. Neural networks can be used for image processing, character recognition, forecasting based on parameters having complex relationships, so-called nonlinear parameters. Neural networks always consist of the same components. The neurons, which is the parameters, synapses, the connection between the parameters, the weights, which are usually 0 to 1 on the synapses based on the likelihood that they will happen, and the biases helps us to fit the data to the model, but also, of course, the function, which determines the output of the neural network. The performance of deep learning functions grow with the amount of data, which this graph shows you, compared to machine learning functions. So why should we use machine learning functions then, when deep learning can do a much better job? Deep learning performs better, but it's basically a black box. You cannot explain how it really works. Compared to more transparent machine learning functions, such as decision trees, which can be defined as a white box, something we can explain. They are great for medical purposes or other sensitive decision making. If you do not have a lot of data, machine learning functions will do a great job, usually even better, since data can easily become overfit with deep learning functions. Last but not least, machine learning functions do not require as much computer power as deep learning do. Today, we have massive amount of data, but do we use it? The answer is yeah, but usually only 1/5 of it. Data can be known or unknown, both saved in the cloud or on a hard disk. The difference is if it can be used for analytical purposes to learn from it. Data that is classified as known data is structured. Unknown data is unstructured. And statistically, about 80% of all data is unstructured or unavailable. And where are those 80% hidden in your company? By identifying the hidden data, you can increase the value of your future machine learning models. So, where can AI take you? It can predict and prevent future behaviors, get a prognosis, insight into complex relationships, that affect an outcome, or replace boring, repetitive work in value chains and operations, and develop new business models, goods, services, and system solutions. It's about increasing quality and efficiency in operation and increasing, of course, the growth rate. Let's take one step further. Today, AI is considered as one of the solutions to solve our greatest challenge, that is, climate change. An example of this is to reach the Sustainable Development Goals using AI. With solutions such as minimized heat and electricity use, or peak demand, and increased information security, or improved economic forecast and analysis. I'm sure you can find yourself in this list. Let's have a look at the possibilities with data science compared to business intelligence. On the y-axis, you see the range of the data knowledge. And on the x-axis, you see the range of how well we know the questions asked about the data. Today, many companies use business intelligence to mainly describe and evaluate what has happened, but also to answer questions that you know about. With business intelligence, you gain insight into how individual parameters affect an outcome. For example, how weather affected energy consumption. The analysis is usually not automated and shows what the connection looked like in a historical timeline. The next step is predictive analysis using data science. This to gain insight on how relationships between parameters affect an outcome. For example, human behavior affects sudden change of indoor climate. The connection depends on several parameters that can be linked in different ways and are very difficult to distinguish with the eye. The analysis is automated and shows a forecast for future outcome based on the given parameters. So to summarize this slide, business intelligence tells you what has happened and why, while data science is able to tell you what could happen and when, just to keep those two apart. Okay? Lots of data sources, structured in different ways, are collected continuously to a storage site. With these different data sources, we can create new insight. But we need to retrieve data from storage on an ongoing basis to learn from this data. The next step is to check and adjust these metrics used before we build the model. Models built can then be used to discover insight in the form of relationships, to find out what the influences what. This means that we understand factors that are important for certain relationships. Well, the end game leads to lessons learned to streamline operations that always develop in a loop. Measure, build, learn. Measure, build, learn. There are several issues that a company wants to start working with AI will face. The most obvious one is, of course, access to the right competencies, and is often what we start to think of when planning to introduce AI. But I would like to highlight something that perhaps hasn't been put to the spotlight enough, or ever. Energy. AI is not a limited resource. And what do I mean when I say that? Well, since AI is heavily dependent on energy, in this case, electricity. And electricity is today not an endless resource. we are limited by the amount available. Training a machine learning model takes a lot of energy, so we need to think sustainable when developing it. If we also add on top of that 85% of the data projects that includes machine learning do not go into production, we need to be selecting and think responsibly when qualifying or disqualifying projects. I wanted to put my script here because this is so important. Training a single AI model can emit as much carbon as 5 cars in their lifetimes, including the energy needed to build it, of course. But deep learning has a terrible carbon footprint. The energy required to power cutting-edge AI has been on a steep upward curve for some time now. The computing power required has increased with 300,000 times higher electricity consumption between 2012 and 2018. That's 6 years. So let's have a look at a different example, which maybe you can relate to. Rubik's Cube. To solve a Rubik's Cube, it consumes 2.8 gigawatt hours. It's hard to grasp that, but if we equal that to CO2 emission by plane, it's a round trip 1,700 times Japan to Europe. And as more companies across industries begin to use AI, there's a growing fear that that technology will only deepen the climate crisis. So what can we do about it? We need to build AI models that doesn't hurt Mother Earth. But what do I mean when I say that? Well, we need to create sustainable solutions, a sustainable infrastructure for our AI models. First of all, use power from renewable resources. Second, use data centers that reuse the heat created by the data centers, which eGain does today by using Google. And they claim zero net carbon emission. We need to use the energy efficient and wisely when engineering our constraints and training our models when really needed. Run your training during nighttime or when electricity is cheaper. Last but not least, we need to become transparent. This by tracking the performance of the code to include some measure of the energy or carbon footprint of algorithms developed and used. So start to measure how energy efficient your AI algorithm is. This by comparing how useful your AI model is versus how much energy was consumed creating it and using it. Let's have a look at the working process now as a 1, 2, 3 step of creating a machine learning or deep learning model. It always begins with collecting and preparing data for training and testing a machine learning model. It ends with a development of the final model so it can be used to predict an outcome with new incoming data. And the majority of the time put at is on the first step, which is about 80%. The first step is data collection. It involves as well integration, access, exploration, cleansing, feature engineering, and selecting features to minimize bias, overfitting by the algorithm. This step can be revisited many times in a loop to improve the model. Next step is to select the algorithm to test and evaluate. This is done by splitting data into a test and training set. After doing model training and evaluation, we will select an algorithm and try to optimize the model before exporting it to deployment. At this last step of deployment, we make the model operationalized to predict outcomes based on new incoming data. The new insights and results coming out from this model will always be written back to the dataset for future retraining of the model. The operations of the model needs to be scored and monitored to keep track of how well it performs and streamline the data, and on new streamlined data. So, eGain will participate in the Horizon 2020 project, Response, to develop energy efficient, smart and sustainable cities. We will contribute with deep knowledge within buildings, system connectivity, data analytics, and energy use. In Response, we will primarily develop the IoT and reporting platform and use artificial intelligence for cybersecurity and energy optimization. This is a project that will run for about 5 years, and when we are done, we will have a blueprint for smart and sustainable cities. To strengthen the situational awareness in the Response project, we are going to develop real-time anomaly detection of the indoor climate. It will, based on the incoming data, calculate the probability of indoor climate deviating from the expected trend. Do you remember the 1, 2, 3 step working process I mentioned before? You can find it down bottom corner. We will start by collecting the data and preparing the data for from local weather forecast, indoor temperature measurements, heating control settings, and other parameters. The next step is to select the machine learning function we believe will do a good job at predicting, detecting of anomaly of the indoor climate. And we need to split up the data and do exactly as I described before. And finally, we will evaluate and track the model performance to optimize it before exporting it. And the final step in this deployment model is to use an API in our case to transfer data between the different systems. But I see the time is running out, and this is my final slide, and I would like to thank you for being at this session, and I hope I have inspired you on how to get started with AI and where it can take you. AI can solve many problems, but use AI where it does a major difference. Create a sustainable infrastructure for developing AI. I will end with a brilliant quote: "With great power comes great responsibility." And Victor,
Yeah.
if you have any questions to us, send us an email and we'll do our best to respond as soon as possible. And we'll look at the questions if we have any. Please write them in the chat or email us. But thank you for listening.
Thank you, everyone. Thank you, Mitra.
Thank you, Victor.